Hello everyone, welcome to the webinar. I'm Isa and I'll be your speaker for today. I am from NTUC LearningHub and we're a social enterprise. So part of our social mission is to make sure that upskilling remains accessible to workers in Singapore as well as companies in Singapore. So we do that by partnering up with some of the top companies and as well as creating our own content to make sure that people in Singapore will get access to high quality adult education. So a little bit about the talk today. We have an interesting topic for you. It is on artificial intelligence. Most of you know that now we're in the information age, and that means something. I think we know that our data are increasingly becoming more important and more valuable. And also we see that every day more and more of our tasks can be done by artificial intelligence. So this also raises some natural questions. A lot of you might be wondering what is the limitations of AI. What can AI do and what can't AI do? And also, let's say if AI is going to be so important, how can I take advantage of this, right? So this kind of natural questions that you have about AI is something that we will be answering in this webinar. And also, we will be going through the history of AI. So you'll get to know about how AI came to be as well, and how AI works. What exactly is AI? So without further ado, let's get started. So if you want to learn about AI, it is pretty useful for you to know about this man. So I wonder whether any one of you know about who this person is. So this is Alan Turing. So Alan Turing is a great scientist. He is at the same caliber as Sir Isaac Newton as well as Albert Einstein. So he's also multi-talented. He is a computer scientist, mathematician, logician, crypto analyst, and so on. So a long time ago, when he was a scientist, the World War broke out. And he was part of the Allied forces, of course. And during the war, when you want to communicate from one soldier to another, you do so by using signal sets. What it does is that it shoots out electromagnetic wave. Okay, so the sender sends out these signals, and the receiver will then pull up an antenna to receive the signals. The problem is that anyone can pull out an antenna, so anyone can hear into the signals. So this is bad. There's no secret. Everybody can hear into each other's messages. So what they normally do is they try to scramble up the messages, and the Germans use this Enigma machine. So how it works is that you see there is a keyboard on this Enigma machine. They key in the message, and the scrambled message will appear littered up over here. Okay? Over the other side, they receive the scrambled up message, and then they'll key in the scrambled up message on their own Enigma machine, and what will light up would then be the unscrambled message. So you scramble the message, you send it over, the other side, they unscramble the message. So if you do intercept their message, you still have to unscramble it, which you can't. Why? Some of you might be wondering, why can't the Allied forces just have an Enigma machine and unscramble the message, right? The reason is that not only do you need an Enigma machine to unscramble the message, but also you need to have the same setting on both sides. So the sender would have the same roto setting here. Can you see there's some dials here? With the receiver. So both the sender and the receiver must have the same settings. Then this will work. So if you are the Allied forces and you want to unscramble the message, you have to figure out what is the correct setting in order to unscramble this. And it's not so easy last time. The reason is that there's a lot of combination and they don't have computers back then. So what Alan Turing did was that he created sort of like a computer. It's a computing device, but it is not the computer that we know of today. It is made out of magnets and coils, okay? But in short, he managed to unscramble a lot of messages. So he is a war hero. So these same scientists then came out with the test to define what AI is. So this test is called the Turing Test. And what it does is that if you have a computer or a program that passed the Turing test, you can almost say that it is a perfect AI, so to speak. So a great scientist, a war hero, came out with a test to define AI. Wouldn't it be very interesting for you to find out what this test is? So allow me to tell you what it is. So the Turing test works like this. You have a person C that is standing behind a wall. He can't see through the wall. On one side of the wall is a human being, and on the other side of the wall is a computer. Now, he talked to both sides using a messaging system. He types out the message. Both sides will get that message, and they will read it. So the computer will read, maybe someone type in the message into the computer, whereas the human being can just read, right? The human being then typed out the reply to the message. They are having a conversation, right? And then they send it over to person C. And the computer A can just print out the message and then send it over to person C. They can't communicate using voice because verbal communication will be like cheating. Person C will be able to tell from the voice of person B whether it is a human being or not, right? So you can easily discern a computer from the synthesis of the voice. So that's not fair. You can only communicate through letter. Now, after a lot of conversation through this means of a letter from person C to A and B, you then ask person C, which side of the wall is a computer and which side of the wall is a human being? If person C can't tell which side is human being and which side is a computer, the computer A is sort of indistinguishable from a human being, right? And therefore, computer A is said to have passed the Turing test. It is a perfect AI. So let's ponder upon that for a second. So what do you think? Does that make sense? Is that a good test for AI? Well, at face value, it sort of is, right? I mean, if a computer is indistinguishable from a human being, then maybe it is a human being. Well, actually not. And I'll give you an example to show you why the Turing test wasn't really a great test for AI. Okay. So there was one program that was able to beat the Turing test back then. It is called Elixir, and it was coded in 1964 to 1966 by MIT AI Lab by Joseph Weizenbaum. And it was created in the 1960s. So have that in your perspective, all right? In 1960s, I think a lot of you know, computers are extremely slow, computers are extremely expensive. So this can't be a very sophisticated software. It can't be too complicated because computers aren't very fast at all. So how can it beat the Turing test? It begs the question, right? How can it beat the Turing test? Let's have a look at the Elixir program. Okay, let me load it up for you. Okay, just a moment. Okay, let me show you the screen now. Okay, so we are now talking to Elixir. Remember, it's a 1960s software. Can't be that amazing. Let's try. So it says, hello, I'm Elixir. Hi, Elixir. Let's see how she responds. How are you today? What would you like to discuss? So I am stressed right now. I'm stressed right now. What does Elixir say? Do you come to me because you're stressed right now? So far, very human. Yeah, I am in front of a large crowd and that makes me nervous. How about that? And she replies, how long have you been in front of a large crowd and that makes you nervous? It's starting to unravel a little bit, but it's still pretty human, right? Okay, let's go further. A long time. I hate this feeling. Let's try. Say, do you have any psychological problems? Not that I know of. Can you elaborate on that? Well, I don't think I have any emotional issues, for example. That's right. Well, I don't think I have any emotional issues, for example. Okay, let me see. It did not scroll down. Why don't you think you have any emotional issues, for example? So let's try to ask Elixir a question. Have you eaten your lunch? The reply would be, let's see. You're not really talking about me, are you? So what Elixir does is that it doesn't allow you to talk to it. It wouldn't be able to give you new information. And also what Elixir does is that it uses templated replies. When you say I am, followed by anything else after that, it copies that message and pastes it into a templated answer. So she will, for example, say, how long have you been, followed by a paste operation of whatever that you just said. And she will also go and replace, when you say I, it replaces with you. Okay, and it does that templated reply. So let me show you an example. Let's have a look here. This one, right? I am in front of a large crowd and that makes me nervous. She replies, how long have you been, followed by a paste operation in front of a large crowd, and that makes you nervous. Yeah, can you see that? So can you see that without even doing very intelligent things, obviously Elixir is not a human being, but it is exhibiting very human-like behavior. So therein lies one of the problems with the Turing test, because you don't need to be exhibiting very intelligent behavior to seem human, and you just need to seem human to pass the Turing test. I give you another example. There's one AI that behaves like a kid that is having a tantrum. Any one of you have kids that has tantrums? You definitely know how they behave. They'll go like, I do not want to listen to you. I don't care. I don't know. I hate you. That kind of reply. It doesn't matter what you tell to the kid. He or she will reply the same way. Can we get a program to copy that behavior? In fact, someone did. They copied that kind of behavior. I think it's called Perry. And the thing is, Perry is not very smart. It keeps saying the same kind of things. So is it intelligent? It is not. But can it pass the Turing test? It certainly can, because it behaves extremely in a human-like manner. So Turing test doesn't work because you don't have to be intelligent or behaving intelligently in order to seem human. And secondly, it matters who is person C. You saw just now there was person C to discern which side is a machine and which side is not. So if a person C is a scientist, that person will be able to discern better. If the person is, for example, my great-grandmother in the 1960s looking at Elixir, she will not be very familiar with technology now. And she will be not in the position to tell apart whether it's an AI or otherwise, right? So that's the weaknesses from the Turing test. So let's go further. Actually, one of the issues is that what Turing is trying to do is define general AI. General AI is AI like R2D2 or C3PO. It can keep learning new things. So for example, you can tell C3PO, okay, let me teach you how to play the game of pool. Let me teach you how to play poker. Let me teach you how to sweep the floor. C3PO can learn that and subsequently be good at it. So it can generally learn new things. And also the same way like the robotic maid in the cartoon The Jetsons, for example. The problem with general AI is that we are not getting anywhere very far. So right now the progress that we have for general AI is pretty limited. But we do have a lot of progress for weak or narrow AI. So we have weak or narrow AI is AI that does one thing. It might do that one thing very well, better than you, but it can only do that one thing only. So whatever you program it to do, what you teach it to do, it can do that. But it cannot generally learn new things by itself. So for example, you can have a machine that plays the game of Go or the game of chess, but if that same machine you tell it to play Counter-Strike or Dota, it can't. It can only play these two games. You can have a machine that can identify faults in the production line or recognize faces and so on. So weak and narrow AI is not very trivial, although we say that it is not general AI, but it is still extremely sophisticated and very interesting indeed. So for the rest of our presentation, I will talk to you more about this weak or narrow AI. Okay, we'll start with a punchy example. One of the most high-profile situation where a machine beat a human being at something. And this is for the game of Go. Now, a lot of you might be thinking, Issa, this is no big deal. It's just a game, right? But it is a big deal. The reason is that the game of Go, right, this Go, has a lot of possibilities. So what it means is that when you are holding a piece and you want to put it onto the board, right, there are immense amount of possibilities. And those possibilities is huge to the point that computers shouldn't be able to play it very well at all, right? So we didn't expect with our computing power, we'll be this good at playing Go. But we did get that good at playing Go. Let's have a look.
There's only one type of move. You just place that piece on the board. And then your goal is to create a linked group of your stones that surrounds some empty territory. And when you surround enemy stones, you capture them and remove them from the board. You earn points by surrounding territory, and at the end of the game, the person with the most territory wins. It seems really simple, but then you sit down to play and you realize right away, it's like, well, I technically know what I'm allowed to do, but I have no clue what I should do.
Go is incredibly challenging for computers to tackle because compared to, say, chess, the number of possible moves in a position is much larger. In chess, it's about 20. In Go, it's about 200. And the number of possible configurations of the board is more than the number of atoms in the universe. So even if you took all the computers in the world and ran them for 1 million years, that wouldn't be enough compute power to calculate all the possible variations. If you ask...
So yeah, you heard that, right? It's pretty amazing. It says that the possible moves in Go is so huge, it's bigger than the number of atoms in the universe. And if you run a computer for 1 million years, you can still run through all the variations in Go. So that's pretty amazing that even though that is true, the AlphaGo team from Google was able to beat the world champion in Go. And while I see that that is amazing, you should really watch that documentary, the one that I shown you just now. It's on YouTube. You just search for Lee Sedol and AlphaGo, and you'll watch the documentary. It's very dramatic. The human player actually did do quite well on one game. And it was quite amazing that he beat the AlphaGo. So if you have nothing to watch tonight, maybe that's the show you might want to watch. Okay, let's move on further, because now I want to tell you exactly what AI is. So far we've been giving you an introduction. Let's dive into what AI is exactly. Okay, so when we talk about AI today, a lot of times we are talking about machine learning. So artificial intelligence is anything that exhibit human-like intelligence, right? But when we talk about AI today, the method that achieve a lot of success today is machine learning. So I want to tell you what machine learning is, but I want to tell you in a case study manner. So let's go into a fictitious company that we're all in. Our company is called Predicti House. It predicts what house you like. Okay, so we have two information that we have. We have a database of tenant information, potential tenants, people who are looking for a place to rent. And then we have house information, places that we want to rent out. The key is that we want to create a software that when we pick one tenant and we pick one house, it's able to tell us how much this tenant will like that house. Got it? So we pick one tenant, we pick one house. The software will tell us from a scale of 0 to 9 whether this person will like the house or not. Why this is important? It's because now if I do have this software, I can quickly just match people to the correct house and we can make a lot of money. Our company, Predictive House, will do very well. Sounds quite realistic, right? Okay, let's see how we can approach this. Well, traditionally, we achieve intelligence by designing a set of rules and mathematics to take the input and get the output. So our input is the tenant information and the house information. This is what we want to feed into the machine. The machine must output whether it is satisfied or not, the person is satisfied or not. Okay? So in order to map the input and generate out the output, we need to create a formula, right? And in order for us to create a formula, we hire very smart people to generate the formula. But think for it for a second. Do you think you can create a formula for this? I mean, a lot of this part, I mean, for me, for you to know whether I will like a house or not, you need to model my mind, right? What I'm thinking, what's my emotion. We don't really know what's happening in the human brain. We don't really have a good model of the human brain right now. So that means, how are you going to create a formula to describe my emotion for a house, for example? Not very easy at all. It's quite abstract. So that is why it is almost impossible for us to even hire people to enable us to model this, right? For them to have the input of the person, the tenant, and the house, and then the formula will then generate what this person will like with the 0 to 9. It's quite impossible. So how do we approach this? This is where machine learning thrives. In situations where creating a formula is too abstract, it's not so easy for human beings to create, we sometimes have a shot at it using data. Let me show you how it works. So using the machine learning approach, what we do is that we create a survey. So we have, let's say, 1 million people, tenants, who already moved into a house. They're already renting. We conduct a survey. Maybe we pay them some money. We want to collect some data. We collect their data, the tenant data. So what's the name, ethnicity, age, height, what food they like. The information must be as detailed and as rich as possible so that we stand a chance. And then we do the same for the house. Maybe what decor it is, what size, square footage, where it is located, what floor, all that kind of stuff, as rich as possible. And lastly, and importantly, we have to ask the tenant, from a scale of 0 to 9, how much do you like the property, right? And now we are left with this stack of data. We have 3 stacks of data. The input data, which is the tenant info and the house info, and the output data, which is 0 to 9, whether the corresponding tenant likes the house or not. 1 million of those. That's why it's quite thick. So the height is trying to tell you there's 1 million data. So the next step that you do, right, is you split the data into 2 parts. 70% of the data is going to be used to train the machine. Okay, so that means we are going to make the machine smart using 70% of the data. 30% of the data is not going to be used to train the machine at all. It's just going to be used to test the machine, to check how well the machine is performing. So some of you might be asking me, I'm pretty sure, Isa, why would you want to waste your data on, testing the machine? Why not use all the data to train the machine? The reason is simple. If you do not know how well the machine performs, then you will not be able to use it. So for example, for me, if we use 99% of our data or just 100% of the data on training, and then we use it for our use case, and then we try to match people to their houses wrongly, then we might lose money, right? So testing the machine is incredibly important, because in order for you to know whether your machine learning model is good enough for your business use case, you need to test it first. Okay? So that is why do not use all the data for training. So 30% of the data, use it for testing. Okay? Okay, so then we start training the machine. So this is how it works. So maybe we come with the first data. So the first data is a guy called Zach. That is the tenant. So he is 25 years of age, let's say, and so on and so forth, the person's data. And then the property that he's in is in Clementi, is on the 15th floor, and so on. Yeah, maybe it is modern decor or whatever. And then it goes inside the machine. The machine is right now not trained at all. So there's no way for it to get it right. It is like an empty brain, empty jar. So it'll just guess a 0 to 9. So it'll guess 3. And sure enough, it got it wrong, because we got the answer. We asked Zach inside the survey. So Zach, in fact, loved the property. It's an 8. So the error is 8 minus 5. 8 minus 3, which is 5. So 5 is the error. So whenever there is an error, the machine is told to change itself, adjust a bit better, in order to make sure that the next time around, the error gets lesser. Got it? The bigger the error, the more adjustment the machine should make. Okay, then the next person, maybe it is Jane. Jane is maybe 50 years old, and she's staying in, let's say, Bedok, and on the second floor, and so on. And apparently Jane, okay, so this information we push inside the machine, and apparently the machine thinks that Jane will love the house, but in fact we know that Jane hates the house. So 2. So the error here is again 5. The machine will adjust itself. On the 700,000 data, we train the machine 700,000 times. The 700,000 data, the data might be, let's say, Bob, right? So Bob is 30 years of age, and the place is maybe in Tampines, and all that data go inside the machine. Machine saying Bob actually will love the house. It's 9. And what do you know? Bob really loved the house because the machine was able to adjust itself to figure out that Bob will like the house from the 700,000 data that it had trained on. So what's actually happening is that this box inside here, right, has a machine learning algorithm. So what it is that a machine learning algorithm will adjust itself to make the error lower. So instead of you hiring a scientist to create the formula for you, the machine learning algorithm will create the formula for you using data. So it's automatically creating a formula for you, automatically. So that's what's happening. A machine learning algorithm is automatically creating for you a formula to get your desired output through the data that you feed it. That's what machine learning is. Got it? And yeah, so that's very interesting, right? And then after that, the rest of the data, you use it to test the machine learning model, check how well it does. No more training. So no more like correcting the machine learning model. You just want to check how many percent of it the machine got it right and how many percent it got it wrong. And then you can then see whether it is good enough for your use case. So now that you know what machine learning is, let me talk to you about why now. A lot of you might be wondering, Isa, why is it that AI is very big now and not in the past? So there's 2 reasons for this. One is data, and the other reason is computational power. Okay? So the first thing is, in the past, right, data is all not available in the digital format. Most data that you want is on analog format, right? For example, if you take a photo, then it is on film, right, isn't it? It's not on a hard drive. You have to scan it to put it on a hard drive. There's no digital cameras. Same with audio. Audio is on vinyl, for example, or in cassette tapes. It is not in CD format or some kind of audio format, MP3 or something like that. So because of that, you can't use it to train AI. It is not in a format that the AI can consume. So how to train AI? Also, data itself is getting bigger now because of the internet. Every time you log into your browser, you go in social media, whatever you do, there's some kind of data that you are creating, right? Even when you go outside, there's cameras outside everywhere, CCTV. You are creating data. So a lot of data are being generated every day nowadays. And that same data can be used to train machine learning models. And that is why now and not before. Okay, there's a lot more data, and also data can be stored more affordably. Last time you can't store data affordably. Now you can buy hard disks much cheaper and you can store the data. Secondly, the stuff that we spoke about just now, about the fact that we need to train the machine, right? It requires a lot of computing power, you know. It takes quite a lot of computing power. And so in the past, they were not able to train the machine because the computer was too slow. And now we have faster computers and we are able to do it. But even now we can benefit from even faster computers. And if you notice, a lot of companies nowadays are investing into that. NVIDIA, Intel, AMD, everybody's fighting in this space. Okay? They want to be the top guys to do machines that do AI computation, training of AI models. Okay, let's move on. So now that you know what machine learning is, let me tell you a few examples. This is the ABC of the example. This is the most basic one. It's called the MNIST dataset. So when you start learning machine learning, this is the first one that you learn. So what you have as an input is an image of the handwriting of a number. an image of a handwriting of a number. So that's the input. The output is you want the machine to be able to recognize the number and tell you what the number is. So for example, obviously this is number 5, this is number 0, and this is number 4. And the output here is 504. So the data set consists of input images of numbers being written and output of what the label is. What is that number? Okay, and then you train the machine and it's able to tell. So I want to show you how the box look like. You know, we saw the green box inside. I told you it trains and it gets smarter and smarter and it's able to tell you what's the output. Let's have a peek on how it looks like. So just for those of you who are in the know, the algorithm here is called artificial neural network because it resembles a brain. So this is one very popular machine learning algorithm. Okay, so let's have a look. Okay, what you're looking at is that, okay, let me see, I'm not sharing the screen. So what you're looking at is that this screen here is a screen of pixels, right? The pixel is the image of the handwriting. You can see this is number 0. And the pixels are exciting white color stuff behind it, which is the neural networks. You have a look. So these are different numbers being fed in, right? And right here, the stuff over here is actually mathematics. It's multiplication, addition, and some operations, okay? And when you put them together, it looks like this. It looks like the human brain sort of is artificial neural network. And the pixels that light up will excite the neural network. Actually, it's actually an operation of multiplication and addition. And at the end of all that operations, right at the end, it will tell you what number it is. Can you see? 0. Right now it's number 2. Now it's number 3. So it's guessing what number it is. So all the maths is inside this stuff that you see here. So this is not fake. This is actually an actual visualization of what neural nets look like. So very interesting indeed, right? Okay. The next example is on image recognition. Okay, so this is called the CIFAR10 dataset. The input is image, and the output is you want to know what's inside the image. So the dataset must consist of both the input and output, like what we did just now. So it must have both the image and the label for the image. For example, this is a sheep, this is a dog. So you train the machine learning model, train with all the data, and then you just give it the input, which is the image, and suddenly it will be able to tell you what's inside the image recognition. And so let me show you the mother of all image recognition data set. Okay, it's called the ImageNet. It's huge. It's 14 million labeled images. Some people actually label 14 million images. Isn't that amazing? And with that, you can train a machine learning model or an AI that is able to tell you what's inside the picture. And that is why your camera can do that. Do you guys notice that now your camera can tell you what you're pointing at? So if you're pointing at food, it becomes food mode. If you're pointing at the forest, it'll go to nature mode and so on. Yeah, it's because of this kind of technology. So let me show you a bit of that. So you can see that, yeah, it is within a video, it's able to create a bounding box and then tell you what is inside. For example, these are airplanes and just now was elephants. And I just want to tell you this amazing fact. The ImageNet competition has created some amazing AI in terms of image recognition. And the top AIs, right, is not only able to do image recognition well, but also it's able to beat human beings at image recognition. That means if you have a human being and the AI to recognize images, the AI will do better. Isn't that amazing? But there's no cause for concern because this AI is a narrow AI and it can only do that and that only, like what we learned earlier. Okay, let's move on to the next use case. And the next one I think you will love because this is my favorite. Let me show you. Okay, this one. Okay, this is it's an AI that creates fake faces. Okay, the first box here, we have two machine learning models. So the first one is called a generator. And the generator's job is to create a fake face. So you tell it what fake face you want. So I want a fake face with a blonde hair. I want a fake face which is male. I want a fake face which is long, or whatever you want. You tell the generator. It will try to generate the fake face at first very badly, and then later on it gets better. So it will generate a fake face, and then it will feed it to its enemy. Its enemy is called a discriminator. So the discriminator's job is to tell whether the image that is being fed to it is a real image or a fake image. So it's able to discern between a fake one and a real one. A fake one is created by the generator. A real one is the one that is here. We will feed it a real image. So what happens is that the discriminator will at first be terrible at its job, and when it gets it wrong, when it says that this is a real image, right, coming in, and then it says false, it's a fake image, then the discriminator has an error, and then it will correct itself. It will keep correcting itself to the point that it gets better and better at discerning between real and fake images, and then it starts getting it all correct. The generator, on the other hand, when it feeds a fake image to the discriminator, and then the discriminator successfully tells that it is a fake image, the generator loses. So it gets an error. So the generator gets an error when the discriminator successfully tells that it is a fake face. So every time it failed to trick the discriminator, it will correct itself. It will have an error. So basically, the discriminator and the generator will fight each other to the point that both of them will get really good at making fake faces and discerning between fake and real faces. And when both of them get really strong, and this is called generative because you're generating a picture like the generator, adversarial because they are adversaries, they are fighting with each other, networks. And after both of them get really strong, what you do is that you remove the discriminator. You just look at the generator. So what do you have in front of you? What is the generator? Think about it. You have a means to create fake faces, right? Not real ones. These are all made up faces. So you can just input whatever facial features that you want, and you can generate the fake face. So you can see here, ball bangs or whatever. You can make the fake face. Some guy did something more interesting than that. They create fake manga faces. So instead of fake human real faces, they create fake manga faces. Let me show you this example. It's very interesting indeed. So they fed in real manga photos, and the generator had to fake manga photos. So these are the features of the character, like long hair, side ponytail, or whatever. I'm just going to shuffle it. All the properties will shuffle. It will generate a new manga image. So you can see that it's currently generating new and completely novel manga images, right? Or sort of novel. I mean, it is going to use the training sets that it had, but isn't it absolutely amazing? I think it is, right? It is as though machines has learned how to be creative. Okay, so that's an example that is like that, but it's even more mind-blowing. So let me show you. So this is it. Let me show you what it is. Okay, the top 4 images here, right? You will use the gender, age, hair length, glasses, and the pose. The bottom left here is everything else are the features you're going to use that. The bottom 4 here will be the combination of the top 4 with the source A here with source B. So that means you combine source B, everything else, with source A, gender, age, hair length, and glasses and pose. So for example, this lady plus this lady equals to this lady. This boy plus this lady equals to this boy. And you see, it's absolutely amazing. These 4 persons do not exist. They are not real, but it looks so real, right? Doesn't it? You can see further a few more examples. Okay, let's pause this. Isn't it amazing? Another Asian. So this guy became this guy. This lady became this lady. This boy became this boy. So in terms of cybersecurity, be careful. A lot of things that you see online might not be real things. They might be fake personalities. People can create fake characters now using this technology. Okay, moving on. I want to talk to you more about, so now that you know what machine learning is and you saw some applications of machine learning, I want to talk to you more about the job roles in machine learning. So let's just keep right to that. So in terms of job roles for machine learning, there are three. One is data engineer, the other is data analyst, and the thirdly is data scientist. So the data engineer is a job role where when you want to do machine learning or data science in an enterprise setting, you need someone to take care of the programming of the data, how to store the data and so on, the database and the infrastructure and so on. So this data engineer is more of a programmer type. And I don't think for the most of us, we will want to go into this route because you need to be more of a programmer type to go into this job role. The next one is the data scientist. Data scientist is a person who is a great programmer and also great at mathematics. So they create new machine learning models for the companies to innovate or do new things. Okay, you can become a data scientist, but you have to learn the mathematics and learn the tools to become a data scientist. Lastly is the data analyst, and I think this is the one that is at the sweet spot where it can improve your employability. So data analyst is a person who understands processes, uses business intelligence tool to perform analysis, to extract value, able to perform data storytelling, to create a narrative on the analyzed data, and create appropriate visualization to enable user to infer important information. And so you need to learn tools such as Excel. Excel is important. And then BI tool, a business intelligence tool. And also it's useful for you to know Python. Python is a immensely popular data analytics sort of software. So with the AI revolution underway now, I mean, AI is getting bigger and bigger. It is very important for everyone to gain some data skills because you can certainly apply it to your workplace. I mean, all of us, including myself, there are data that I use in my workplace that I can analyze using data analytics. And by doing so, you are aligning it to the current trajectory of different what the companies are doing. So right now, companies are going for a data strategy whereby they look at the kind of data that is flowing into the organization and see how they can create additional value through this data. As you can see, when you have a lot of data, you can create AI models. So they're looking at how can I create AI models or something of value like that using the data that I already have, right? So you as the employee within these companies would like to position yourself to be able to be data driven as well. And you do so by learning data analytics skills. So we have some courses to help you get underway with this, and they are funded. So the first one is Data Analysis Fundamentals using Microsoft Excel. And Excel is important because a lot of the enterprise data out there is residing in Excel spreadsheets. So to be able to max out on Excel is incredibly useful. So it is $780 or $834.60 after GST. After funding from the IBF, okay, listen on the eligibility. You must be Singaporeans or PR. And 95% is up till July or June 30th. July 1st onwards, it will be 90% funding instead. And you must be self-sponsored. That means you're paying for yourself. Okay, for companies, it will be different. You have to inquire to us. You'll get this very generous 95% funding. And not only that, you can pay for it using your SkillsFuture credit. Okay, that's terms and condition applies, of course. You can get to know it from us. But it's an amazingly great deal for if you want to start learning about how to analyze data using Excel. Next are 2 Python courses. Before you can attend them, you must know some Python programming. That means you just need to know basic Python programming. That's all that we ask for this first one. It will teach you how to create interactive dashboards using Python to analyze the data. Okay? And it is $1,000 for a 2 days course, but it is with 95% funding, just $53.50. Okay? With the same conditions that I spoke about earlier. Okay. And there's another one which is machine learning, the stuff that we spoke about just now, the MNIST dataset and so on. And it's the same price as the dashboard course. Okay, same thing, Singaporeans and PR before July 1st. And lastly, we have a very advanced course. So if you already already know Python very well, then you want to go into this course for AWS. It's aligned to the official AWS Amazon Web Services certification. Okay, so it is $3,400, and with after 95% funding before July 1st. After July 1st, it will be 90% funding all the way to December 31st. Okay, then the funding change again. So yeah, go for it now, because I think the funding level is certainly pretty attractive. Okay, if you are keen, I created a form to make it easy for you to sign up. You can use this QR code. Okay, so I hope this talk has been useful for you. So yeah, we tried to squeeze in as much information as I could so that you can have a greater appreciation for what artificial intelligence is. It is certainly a very exciting topic, and I hope that you will continue and strive to upskill in this field, because it can only get bigger and bigger. Okay, thank you for having me in this webinar. It has been a pleasure to talk to you. Have a great rest of the day. Bye-bye.